Hey guys, welcome to the Unit 2 review guide video. Let me change this back to regular. Black and white's good. Yes, so the test is on Monday. Calculators are going to be okay. So graphing calculators are going to be okay, but I will talk a bit more about what my expectations are. You'll be able to use them, but you will need to show your work algebraically about why certain things are true, and I'll talk about that in the video. Okay, so we're starting off with some quadratics here. Write an equation for a quadratic function whose graph contains a given vertex and point. So if I'm given a vertex form here is going to be very helpful. So again, vertex form is y equals a x minus h squared plus k, where h comma k is the vertex, right? So here I'm given the vertex, so I can just plug that in. I can have y equals a x plus 2 squared minus 3. However, I need to still get my a. And to get my a, I'm going to use my point here. So my point gives me an x value and a y value. And you probably did this in Algebra 1, but the idea is you just plug in this coordinate into here, and then you solve for a. So we'll have 2 equals a 1 plus 2 squared minus 3, and that's 5 equals 9a. So a equals 5 over 9. sorry. So my equation is y equals 5 over 9 x plus 2 squared minus 3. Okay, so no vertex form, know how to get it into vertex form like the quiz, and then know how to transition between the different forms. Okay, that was the first delta. Divide f of x by g of x. Okay, so this is something you all seem pretty good on. You can choose to do synthetic for this one, or you can do regular long division. I'm going to show regular long division because we'll do synthetic later. So again, for regular long division, we write out our function, and I am making mistakes here, plus 4x minus 5. We're dividing that by x minus 3. We say, okay, what's the biggest factor that goes into x to make 2x to the third, and that is just 2x squared. Put that here, 2x squared, and that gets us 2x to the third minus 6x squared. Subtract both of these. We're going to get 0 here, and then here, be careful when you're subtracting negative, you're actually adding, so this is just a negative x squared. We drop down the 4x. X times what is negative x squared? That's just going to be a minus x. So we have a negative x squared minus 3x, plus 3x, which gives us just an x minus 5 at the end. This is just a 1. So we have x minus 3, subtract, and so we're going to have negative 2. This is our remainder. Okay. So when we write it out, this is my quotient, 2x squared minus x plus 1, and then minus the remainder divided by the divisor. And that's it. Okay. 3 is x minus 2 a factor of x to the third minus 4x squared plus 8x minus 8. So one way you could do this is you could divide it, and if you did not get a remainder, you would know that it's a factor. Another way you could do it is the idea that if this means that x equals 2 is a 0, and so that means that f of 2 must equal 0. So we can just see if that's true. If f of 2 equals 0, then it's a factor. So we'll do 2 to the third minus 4, 2 squared plus 8 times 2 minus 8. 2 to the third is 8. That's minus 16. That's plus 16. And that's minus 8. It is indeed 0. So yes, x minus 2 is a factor. So again, if you plug in a value and you get 0, it is a factor. If it has a remainder, sorry, if it has an output, that would be the remainder if you did divide it by that factor. Okay. All right, continuing on. We got some rational functions here. Find the asymptotes and intercepts of the functions below and then graph them. So again, here, graphing calculator is allowed, but I need you to show algebraically why certain things are true. I need you to know that, right? So like you can't just tell me, oh, there's a y-intercept here or whatever, x-intercept here. You have to like show me how you got that. Okay, you can use your calculator to verify that, but you can't do it from scratch. So easy one is the y-intercept. Y-intercept is just gonna be f of 0. So we plug in the 0, we get 1 over -1. So it's just -1. So my y-intercept is gonna be here at 0, -1. That one's easy. For x-intercepts, you set the numerator equal to 0. So again, you need to show me this, x squared plus x plus 1 equals 0. And you would try and factor this. You can't factor this, but you could try quadratic, which would get you -1 plus or minus the square root of 1 minus 4 over 2. And this is no real solution because you are going to be adding, subtracting, and square root of a negative number. So there are no x-intercepts. Okay. Then we've got the horizontal asymptote. Because the degree and the numerator are the same, you divide the coefficients. So we have horizontal asymptote at, because it's x squared over x squared, at y equals 1. And then we're going to have vertical asymptotes when the denominator is 0. So x squared minus 1 equals 0. So we're going to be at x minus 1 and x plus 1. So x equals 1 and x equals -1. So that means here, so I can fill out some stuff here. We're going to have a vertical asymptote here at -1, here at 1, and I'm going to have a horizontal here asymptote here at 1 as well, y equals 1. So this is kind of like the scaffold. Got it? Okay. And then we can use our calculator to verify here. So I plugged it in for y1, and you can see that aligns with what I've got, and we can sketch it out, making sure we intercept there and here. Okay. Same idea for B, same order, right? So y-intercept is going to be f of 0. Make sure you know how to do all these. Y-intercept, x-intercepts, vertical asymptotes, horizontal asymptotes, whole. F of 0 is going to be just 5 over 3. So 5/3 is going to be up here. What is 5/3? 1 point, like it's around here. Okay. X-intercepts, we're going to set that numerator equal to 0, x squared minus 4x plus 5 equals 0. So it's going to be, can we factor this? Yes, I think. Can we? 1 and 5. No, I'm not seeing a way to factor the numerator, so we can try a quadratic. So it's going to be 4 plus or minus the square root of 16 minus 20 over 2. So again, because this has got us the square root of a negative number, this is no real solution. So there's no x-intercepts. Okay, so just to be clear what I'm doing there, like I'm setting the numerator equal to 0 to find the x-intercepts. In this case, it was not factorable, so I tried a quadratic formula, and I saw that in the quadratic formula, I'm going to have to take the square root of a negative number. If you see that, that means no solutions. It means there's no x-intercepts. Okay. And then the denominator, okay, we have a vertical asymptote at we have a vertical asymptote at x equals -3, and we have no horizontal asymptote because the degree of the top is greater than the bottom. Okay, but because the degree of the numerator is one higher than the denominator, we can have a slant asymptote. So in this case, we have to do an SA. So slant asymptote, you are going to divide the numerator by the denominator, x squared minus 4x plus 5 divided by x plus 3. We'll have x squared plus 3x minus 7x plus 5. So it'll be minus 7. Minus 7x minus 21, so remainder is 26. But what we care about is this x minus 7. That is our slant. And so when we graph it, we can see what's going on. So I put it in for y1, and I put my slant in asymptote for y2. And when I graph it, it looks pretty clear. And when I maybe make that window a little bigger, it's going to be even clearer that I got it right. So again, you're not using your graphing calculator to do the work. You need to show me this work, and then you can use your graphic calculator to verify it. So it's going to look, this is kind of my slant asymptote, like here, and I can zoom 6 so I can see it more clearly. And then we have a vertical asymptote at -3 here, x equals -3, so it's going up like this and hitting here and then going over like this. Okay. All right. Okay, moving on, we have a rational equation. So we did in our very last lesson. Whenever you solve rational equations, like you want to like look at all the terms in the denominator, and also factor out a function if it's like looking a little bit complex. So here, if we factor this out, this is really the same as x minus 3 and x plus 2. And if you see, like, this is the same as these two over here, right? This is x plus 2, this is x minus 3. So the idea is, if we multiply everything by x minus 3 times x plus 2, then we'll be happy. So that's what we're going to do. So we're going to do x minus 3 times x plus 2 times x over x plus 2 plus x minus 3 x plus 2 times 5 over x minus 3 equals 25 over, again, that's just x minus 3 x plus 2 times x minus 3 x plus 2. Everything gets multiplied by x plus 3, x minus 3 x plus 2. So that cancels with that cancels with that cancels with that, and then we multiply the leftovers. So we'll have x squared minus 3x here plus 5x plus 10 equals 25. We'll set this equal to 0, so we're going to get x squared plus 2x minus 15. This factors to x plus 5 and x minus 3. So x equals -5 and x equals 3 are my solutions. But if we test them in, we can see that 3 is not going to work. So only x equals -5. This is our solution. Okay, and you want to test them back in this just to make sure you're good if you have time on the test. But what you're looking for is make sure you're not dividing by either one of these. Okay, here describe the end behavior using limit notation. And I don't mind if you use the x to infinity version. That's okay. We'll go into limits more later in the year. But here what we're looking for the end behavior is that this is even degree and positive leading coefficient. Therefore, it's going to end like this. So we say as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to infinity. Okay? Identify all potential rational roots. So here, we're going to take all the factors of -4 and divide them by all the factors of 1. So we're going to have plus minus 4, plus minus 2, and plus minus 1, all divided by plus minus 1. So this will be 4, -4, 2, -2, and 1, -1. Find the y-intercept. That's just f of 0, guys. F of 0 is going to be just -4. Easy. So now it says find all the zeros using synthetic or polynomial long division for at least the first two. So the idea here is this is what my expectation is. My expectation is you can use the calculator. I'll show you like some ways that you want to use it. So we'll put in x to the 4th plus 4x to the 3rd plus 3x squared minus 4x minus 4. That's my function, right? And we can graph it, right? And take a look at it. And we can see that we have some zeros here. Okay. It looks like -2, -1, and 1. How I would want you to show me that is if we go to home screen and you go to alpha, alpha trace, and we go to y1 parentheses, and we plug in our roots, and I plug in like a 4, I can see that equals something. So I can try, okay, -4, I can try -2, right? So I can see because f of -2 is 0, that's going to be a root. Okay. And then what you would do is show me the long division, or show me the synthetic division. Let's keep going and test the other values. So we can have -1 is also a 0. -1 is also a 0. And we had one more. So just 1, yeah, and f of 1 is also a 0. So by testing this, I can verify, okay, these 3 are all roots. But what's going to happen in the test, right, is you're not going to necessarily get as a clean version like this. Like there may be like imaginary roots or irrational roots. And in that case, that's where I need you to do the synthetic division. So I'll show you like what that looks like so that you're ready for that. So we would take, for example, let's say we figured out that these were roots, like rational roots, but we didn't know what the others were. You're gonna take your function, and we're going to divide it by 2, by -2 rather. So we would do we do the synthetic division here, we'd have 1, 4, 3, -4, and -4, and we would divide that all by -2. So -2 goes here, and we'll do our synthetic division. So 1, -2, 2, -4, -1, 2, -2, 4, 0. So we'd have x cubed plus 2x squared minus x minus 2. Okay. And then we go to another factor, we get rid of, okay, like the 1. So we could set up again 1, 2, -1, -2, and synthetically divide by 1. So we have 1, 1, 3, 3, 2, 2, 0. So then we have x squared plus 3x plus 2. And then at this stage, you can just factor this as x plus 1 and x plus 2 and see that our final ones are x equals -1 and x equals -2. So yes, you can use your calculator, right? And you can help use that to find your those intercepts. But I also need you to be able to synthetically divide to find any remaining roots. Okay, is that clear? It'll be very clear on the test. Like I will say use synthetic division, so I expect you to use synthetic division. Okay. Then we can graph the function. Okay. For the rational function, identify any horizontal asymptotes. Again, for horizontal asymptotes, you want to look at the degree. Since the degree at the top and the numerator are the same, we have a horizontal asymptote at x squared over 2x squared, which is 1 over 2. Identify any vertical asymptotes or holes, so we need to factor the top and bottom. At the top, we're going to get x plus 2 and x minus 2 on top. And on bottom, we'll have, well, first we can factor that as 2x squared plus 5x plus 6, which is the same as 2x plus 2 and x plus 3. So because x plus 2 is appearing twice here, that's going to be a hole at x equals -2, and then we're going to have a vertical asymptote at x equals -3. Do not worry about number C right now. Okay. D. Find all x and y intercepts, if any. So again, for y intercepts, you're just going to find f of 0. So plugging a 0 into this, we're going to get -4 on top and over 12. So we need -4 over 12, which is -1/3. So b 0, -1/3. And then for the x-intercepts, you set the numerator equal to 0. So we're going to have, the numerator again was x plus 2, x minus 2. So x plus 2, x minus 2 equals 0. But remember, -2 was a hole, so we only have an x-intercept at x equals 2. Okay, because -2, this was a hole. Okay, and again, we can use our graphing calculator to verify this. X squared minus 4 on top, 2x squared plus 10x plus 12 on the bottom. So yeah, we're seeing what we described, that vertical asymptote at -3. We can sketch this. Marking that horizontal asymptote. Okay. All right, last couple problems here. So these are more practice of that earlier problem, same kind of question. So here again, you look at the degree is even. the degree is even and the leading coefficient is positive, so as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to infinity. Y-intercept against f of 0, so that's just -6 here. Rational roots would be plus minus 6 over plus minus 1, plus minus 3, plus minus 2, and plus minus 1. Find these zeros using synthetic. So again, what that means is a combination of both graphing calculator and the problem. So we'd have x to the 4th plus 5x to the 3rd plus 5x squared minus 5x minus 6. So we're seeing 4 here. So we know which ones are going to be our roots, and then you're going to show that to be true by synthetically dividing them, like we did before in that earlier question. So it looks like from here that f of -2 is 0, f of -1 is 0, sorry, f of -3 is 0, and f of 1 is 0, which makes sense because we have a degree of 4, and then we can synthetically divide 1, 5, 5, -5, -6 divided by -2. So I got this right. 1, -2, 3. -6. This is -1 minus 1. This is a 2, and that's a -3, and that's a 6. That's a 0. So following this pattern, x to the 3rd plus 3x squared minus x minus 3. So you continue this pattern, right? You keep on breaking it down using this and prove that these are the zeros by synthetically dividing by all of them. And if you have stuff left over at the end, that would be potentially irrational or non-real zeros. It's getting a little loud here, so I'm going to end here, and I will finish this and put it on as an answer key. Good luck with studying, and I'll have office hours on Monday morning.